Hey, what's up, students? Here we are. Example 4, the last example in the I take it back, the 4.2 to 4.4 notes. As you can see, I've already filled in my 7 inputs, my magic super table, the super inputs. Usually -2 to +2 is good enough, but for these quadratics, these squareds, we're going to use a super input list. -3 to 3 is the super input list. So let's go ahead and take our time and put these in. 6 minus 2. Remember, when you're putting in negatives, make sure you use brackets, otherwise you will calculate it erroneously. Don't do that. 6 minus 2 times a -2 squared. 6 minus 2 times a -1 squared. Take your time. You don't need to write it down as fast as me. If you need to pause this so you can catch up, that's no big deal. Take your time and rewrite them carefully. Once you kind of get in a rhythm, it's really not too bad. You just go right to the next one. And then before you know it, you're done. All right, there we go. 7 inputs have been put in. Let's get the outputs. Remember, these are the inputs. These are the outputs. Let's put them in and let's get some coordinate points plotted so we can graph our equation. That's the whole game here, is we're trying to graph these equations, but we got to make coordinate points on our graph, and and then the coordinate points will kind of make the line of the graph. All right, so I'm gonna use my calculator for these bad boys, just because I want to be accurate on this last one. I don't want to trip at the finish line. Here we go. 6 minus 2, new bracket, minus 3, close the bracket, square it. Let me double check, make sure I typed that in right. Looks like I'm good to go. Ooh, -12, okay. -12 is going to be this guy right here. All right. Type it in again. Take the -3 out. Throw in a -2. Minus 2. Close. Not close the bracket. Bracket. Now close the bracket. Then square it. Getting ahead of myself. -2. All right. 6 minus 2. Bracket. -1. Close the bracket. Square it. +4. Mental math, I can do this one. 0 squared is 0. -2 times 0 is 0. I'm guessing this is going to be a 6, but let's double check. It's always good to double check. Weird. 6. All right, cool. All right, 3 more to go. 6 minus 2 times 1 squared is 4. Oh, looks like we're doing a little multiple y value thing again, where they match up and it loops. Nice. 6 minus 2, bracket 2. Close the bracket, square it. -2. Now, I'm not super good at patterns, but I kind of have a funny feeling. Oh, 4, then a 4, -2, then a -2. We might get a 12. Let's find out here. 6 minus 2 times 3, square it, -12. Look at that. Okay. Again, I could have done all this a lot faster. If I get good at using these graphing calculators, I could type 6 minus 2 times x squared. Oh boy, I got to delete all that noise. I don't want that stuff. Go away. Go away. I don't want that or that. There we go. Watch this. Go to the second table. There you go. Look at all those inputs and outputs. Boom. 7 inputs, 7 outputs. That's pretty efficient. Yeah, these things are designed to do this stuff pretty fast. So doing everything by hand, oh buddy, it takes a while. Here's my inputs. -3, -2, -1, 0, 1, 2, and 3 outputs. -12, -2, 4, 6, 4, -2, -12. All right, let's plot these coordinate points and see what happens. Spoiler, I have a funny feeling it's going to be non-linear again, because it's not going to make a straight line. It's going to loop. It's going to get goofy. Let's figure it out here. All right, -3 and -12. So 3 to the left and then down to the 12 is right about there. Here we go. Next one is -2 and -2. 2 to the left, 2 down. There we go. -1 and 4 is going to be 1 to the left, up 4. Let's see here, 0 and 6, 0 and 6. Ooh, it's barely on the window. So when I refer to the window, I'm talking about what we can actually see on the graph. And that's kind of a whole other realm of math, is window manipulation. Sometimes you can zoom in, sometimes you can zoom out. Some of the things we do on Desmos, the window is very, very easy to manipulate. All right, let's get the other coordinate points. 1 and 4 is right there. Here we go. We're coming back around now with this parabola. That's what it's called. We'll learn more about those in the future. 2 and negative 2, positive 3, negative 12. Look at that symmetry. There's left and right symmetry. You got same numbers on the left and the right, symmetry and stuff. Okay, I'm not very good at drawing these. I'll try my best. Oh, terrible. That side wasn't very good. Loop around. Oh, horrendous. Oh, did the best I could though. These are a lot better. That's why we have graphing tools. Not everybody is gifted to draw stuff by hand, myself included. Oh boy. All right, well, I'm just gonna make it worse. All right, so as you can see there, we have a non-linear graph. We had 7 inputs, put them in, got the outputs. Together they made the coordinate points, and then together we made the graph. Do the best you can. Try to do better than me with these curved lines. But otherwise, just take your time, plot the coordinate points. You're gonna be graded more on your ability to find the accurate coordinate points, not your ability to draw beautiful curved or straight lines. So, all right, that's about it. I guess we'll finish this thing off with the last part of the notes here. Continuous graphs versus discrete graphs. So continuous graphs are when the graphs are one solid line. We use this when we want to include decimals in our coordinate points. So if I would have just left those coordinate points alone, I would have called that a discrete graph. But as soon as I connect them all with a line, it's now continuous. So don't think too hard. A discrete graph is when you only would graph individual coordinate points. And sometimes you graph things based off whole items, like when there's no decimals, like when if you're, you have so many actual whole items left, like this would be a graph of you losing one thing at a time, like you're handing out candy bars and you're not cutting them into decimals. You just have this many, then you lose one, then you lose another. You have whole items left. Continuous is when you can throw any decimal you want in there. All right, that's about it. Cool, that's all I got for lessons 4.2 to 4.4. We'll see you in class.